Welcome to this video, which is part of a series of 6 video lectures where I go in detail on the treatment of road runoff. All the information you can find in the 2 links I posted in the description field. So now I invite you to look at this video. Welcome to lecture 3. Now we're going to look at the sedimentation times for suspended solids in runoff water. Here we have an overview over the treatment process for road runoff. Now we are going to focus on the sedimentation properties of the runoff. We are going to look at how to separate the particulate material from the runoff before discharging to the recipient. To find out this, I did several pilot trials in the Eugenia-magasinet. The Eugenia treatment facility is located north of Stockholm in Solna. The catchment area for the Eugenia treatment facility is from the E4 highway, which is very heavily trafficated. The annual average daily traffic is about 100 to 120,000 vehicles per day. On the picture on the right hand side you see the 5 blue sedimentation vessels used for the pilot trials. In each runoff event, these sedimentation vessels were consecutively filled up with road runoff. After the runoff event, the sedimentation trials began. On the left-hand side you have a picture with 2 of the sedimentation vessels. Here you see the taps where I collected samples to measure the turbidity during the sedimentation trials. On the plotted curve, you see the result of one of a total of 49 sedimentation trials. On the y-axis on the graph, you have the average turbidity measured in the sedimentation vessel. On the x-axis, you have the sedimentation time in hour, and the plotted orange dots are the measured turbidity over the sedimentation period. The table shows you the sedimentation time, the calculated reduction, the average value of the turbidity that you also see in the graph, and finally you see the calculated suspended solids concentration based on the turbidity. A total of 49 trials were carried out with de-icing and without de-icing. That is during winter time and summertime in the catchment area. Based on these trials, I made a design tool or an empirical model. The design tool or model I labeled the Hallberg-Eugenia design tool. If you use this design tool, what you need is the input data of the runoff concentration of suspended solids and the suspended solids concentration you want after treatment. With this input, you can get the needed sedimentation time and you can get a surface load for the pond or tank you're going to use for the treatment. On the picture you have an example of a dam. If you know the inlet concentration, in this case 380 milligrams per liter, and what you want out from the dam, 200 milligrams per liter, then you use the model and you can calculate how big your dam is going to be. If you want to know more and have all the details about the model, the correlation between turbidity and suspended solids, put a comment in the commentary field and I will send you paper 4 here. With that, I invite you to Lecture 4, where I'm gonna discuss the particulate and dissolved material in road runoff. Take good care, have a good day, bye bye.